Alright, so our first special product, we saw what happens when we take, if we have two terms that kind of repeat, except one of them is a sum and one is a difference. What happens if they're both the same thing? What happens if I say an x and a 3, except I'm now doing a sum times a sum? Or another way of saying this is I'm squaring this binomial. Well, let's just look to see what happens. I take x times x, which is x squared, x times 3, which is 3x, 3 times x, which is, again, 3x, and 3 times 3, which is 9. So we end up getting x squared plus, you'll notice these two terms are the same thing. And no matter how I do this, if I'm squaring a binomial, they will always end up being the same thing. So I end up essentially doubling what that middle term is. 3x plus 3x is 6x. And then I get my 9. In general, if I have a plus b and I want to square it, this is a plus b times a plus b. And again, I'm just doing this the long way out so we can kind of see where everything is coming from. A times a is a squared, a times b is ab, b times a is ab, and b times b is b squared. These middle two terms, you can see they combine, they match each other, and I have two of them, so I get 2ab. Oops. So a squared plus 2ab plus b squared. This is this is a sum squared. We can do the same thing with a difference squared. When we do it with a difference, though, we'll notice that, let's see, I get a squared, I get a times the opposite of b, so it's minus ab, and we get another minus ab, so minus ab, and then we get a opposite of b times opposite of b, which is a positive b squared. So the negatives, I have two negatives there, which is why they end up canceling. I get a plus b squared. So I get a squared minus 2ab plus b squared. So my difference of squares and my sum of squares, these are my other special products that we're going to see right now. A plus b quantity squared, we sometimes state is a squared plus 2ab plus b squared. And a minus b quantity squared is equal to a squared minus 2ab plus b squared. You can see these look almost identical, except when I'm summing a square, the middle terms end up being both positive. When I'm summing a difference, the middle terms end up being both negative. When both of these, I get an a squared and a b squared, both of those being positive. So let's apply that here. Y plus 7 quantity squared. I'm recognizing that it's a binomial squared, so I'm going to take that first term squared plus 2 times the product of these. So the product of these is 7y. If I double that, I get 14y. And then the second term squared, which is 49.